Hello everyone, today I am going to walk you through something really exciting. We are building a smart weather assistant powered by the Open Weather API and framework called Fast MCP. With just a few lines of Python, you will be able to get real time weather updates, 5-day forecasts, air quality reports, and even search for a city in the world. But that's not all. We are using a modular approach using MCP tools, which means this app can easily be plugged into chatbots, AI assistants, or even your smart home system. So, whether you are a beginner or a developer looking to build an intelligent weather backend, this video is for you. Now, let's walk step by step through the setup using the readme.md file. So first of all, you have to clone this repository. For that, you have to copy the repository link from here. Go to VS Code. As you can see, I have already this repository, so I'm not going to do that. So for you, you will write git clone and paste the link here. It will copy all the files and folders from the GitHub to your local system. So once you clone the repository, you have to change your directory to weather MCP tool hands-on. So now you have to create a virtual environment. To create virtual environment, there are two methods. One is using Python -m venv. It is a traditional one, and you can use uvvenv. So we are using uvvenv to create our virtual environment. So now I pasted the code, hitting enter, and you can see here the VNV folder is created. Now we have to activate it, so we will use this here, and you can see weather MCP tool hands-on virtual environment is activated. So now there are a project.toml file. In the project.toml file, there are some dependencies which you can install. If you are new to UV, then you can use pip install -r requirements.txt. So here are also those dependencies available there. So either you can run pip install -r requirements.txt, or you can run uv sync. Alright, it will install all the dependencies for my project here. So as we are using Open Weather Map to fetch the real-time weather report, we need to set up our .env file here. So for that, you can copy this code, this file here, and paste it here and name it as, alright, you can move it to here. You need to update this one. Remove this and open the readme file. Here you can open this link. Here you need to click on sign in button. In the sign in page, you can see a create an account button here. For that, I am 6. So after filling those information, you have to check these boxes here. Click on I am not a robot and create an account. You can fill other in the purpose and save it. Now they have sent an email to my account, so let's verify it. What we have to verify, you have to click on verify your email here. Now I have verified my account. So now you have to click on here and then my API keys. Here you can see your key is already available. It is mine. I will blur it or deactivate it after the use. So if you want a new key, then you can write here some random name and then generate it. It will add a new key over here. So I have already a key generated by the weather API itself. I'm going to VS Code, pasting the API key, saving the file. Now we can run our project using mcp dev main.py. mcp dev main.py. Press Y and hit enter. So now this interface will open in your browser. Then you have to click on connect to connect this MCP server. And here you can see tools section. We have already talked about resources from tools and all those things. Now you have to click on list tools. It will list all the features, all the tools over here, like get current weather, get weather forecast, get air quality, search location. So we will see all of them one by one. So firstly we will click on get current weather. You can enter your location. As I am in Gurgaon, so I will type Gurgaon and hit run tool. It will provide me the locations detail, Gurgaon, India, longitude, latitude. Then current temperature is 32.05. It feels like 39, and all those things like main. How is the weather condition is like clouds, wind speed, wind degree, and humidity pressure, and all those things we have seen in the code. Now let's move to the get weather forecast. Also, I can put here like Delhi for the days I need. 5 is the maximum value you can check for the 5 days. So if I run location Delhi and for the days too, it will provide me the forecast for every 3 hours. Like you can see 0, 1, 2, 3. There will be 16 results, 8 results for each day, as it is giving details for every 3 hours. So 24 by 3 is 8, and 8 into 2 for 2 days is 16. Then we will see how get air quality index is working. Also, I can put here the location like Nainital and hit run tool button. So it will provide me the air quality. The air quality index is 3, which is moderate, and the components are here. You can see like CO2 is this much, NO is this much, and NO2 and all those things here. So finally, we have search location tool. Here we can search any location in the world. So if I search Paris, and let's see what it will return. So it results like this JSON format, like name is Paris, state is the France, country is France, longitude, latitude, and other places are like Paris, France, Paris, Texas, US country, like all the similar names the API has, it provides us as a result. Now that we have got our project running, using the steps from the README, let's take a deep dive into the heart of the project, our main Python file, main.py. First, we import all the necessary libraries like typing for type hints, fast MCP from the mcp.server.fastmcp module. This is the core tool wrapper, and logging to log info and errors in the console. Then we have requests to make HTTP request to the Open Weather Map API, OS, and .env to handle our environmental variables securely, and date time to format timestamps like sunrise and sunset. We load the environment variable from a .env file using load underscore .env. This is where our API key is stored securely. Then we set up basic logging so we can track server behavior, especially useful for debugging or when errors happen. Now here we initialize our fast MCP agent with the name weather MCP. Next, we try to fetch our OpenWeather API key using os.getEnv. We also define base URLs, one for weather data and one for geolocations. If the key is not found, we log a warning to let the user know. Now let's look at our first and most useful tool, get current weather. This function takes a location like Paris, Delhi and returns detailed weather information. Here is the flow. First, we make a call to the geocoding API to convert the city name into coordinates, latitude and longitude. Then we use those coordinates to make a second call to the actual weather API. We extract values like temperature, humidity, wind, clouds, sunrise and sunset times, and format them all nicely in a JSON dictionary. Finally, we return all the data back to the user. The output is clean, structured, and ready for display in any app or interface. Our next tool is Get Weather Forecast, which works very similarly. Instead of just current coordinates, the function gives you a multi day forecast up to 5 days. It again gets the coordinates using the geocoding API, calls the forecast endpoint from OpenWeather. Each day is split into 8 slots because the API gives data in 3 hours interval. We loop through each time slot and exactly key metrics like temperature, wind, humidity, etc. All forecasts are compiled into a list and returned along with location metadata. Then we have a get air quality tool. It follows the exact same structure as the others. It uses geocoding to get longitude and latitude, then call the air pollution API endpoint, then call the AI pollution API endpoints. The response includes the air quality index AQI and several pollutant levels like CO, NO, NO2, O3, SO2, PM2, PM10, and so on. It also maps the AQI number to the human readable level like good, fair, poor, moderate, very poor. Then we have a search location tool. Last tool in our suite is search location. If the user types in a particular city name or something ambiguous, this tool hits the geocoding endpoint with a limit of 5 results. The results include latitude, longitude, state, and country code for each matching city. In all the tools, we have added the exception block where we are handling the error using the try except. User friendly error messages are bad locations, missing keys, or API issues. This ensures your app never crashes unexpectedly and always returns meaningful feedback. Finally, in the main block, we confirm that the API key was loaded and then run the MCP server. This line mcp.run starts the server and registers all tools so they can be called from an agent or UI front end. So that's a full breakdown of our main.py file in the fast MCP weather project. With just one file, we have created a full weather service capable of current conditions, forecasts, air quality, and smart city searching. From here, you can integrate it with a chatbot, use it in a web app or mobile app, or even build a smart home assistant with this API, powering it behind the scenes. If this helped you understand the backend better, drop a like, leave a comment with questions, and subscribe for more project deep dives like this.